Okay, here is our topic. Here's our objective. All right. Mainly, Q is equal not equal to 1. We want to know what the cell potential is going to be of electrochemical cell. Because standard conditions are when I've got 1 molar, 1 ATM for a gas. And essentially that means Q, for these things, Q's are going to be equal to 1 because of these two conditions. And when we change it, we're going to want to predict it. Because all of the electronic standard cell potentials are for standard conditions. So when the molarities aren't 1, what is it going to be? All right. Now, one thing you got to remember is our reaction quotient is that the concentration of products over reactants. And remember what it means. When Q is less than 1, it means I've got more reactants. When it's equal to 1, I've got equal amounts of each. And when it's less greater than 1, I've got more products. All right, because electrochemical cells can be seen as equilibrium systems, and therefore they're going to the relationships between Q and K allow us to predict what they're going to do. All right, and this means the further I get from my K value, the greater the difference, the more the potential that the cell is going to be. All right, and let's look at it real quickly. The galvanic cells, they look like this. They have a positive delta G, therefore they're going to have a K value that's greater than 1 because they're thermodynamically favored. And the electrolytic cells, they've got a positive delta G, they're going to have a K that's less than 1. And this is going to be important when it goes term to predict them. All right? Because for a voltaic cell or a galvanic cell, your K is going to be greater than 1. Therefore, when Q is less than 1, it's got a long ways to go from where it's at. So my cell is going to be greater than my standard values. This is going to increase the magnitude of the cell in terms of its potential. And it's the opposite when Q is greater than 1, because now I'm getting closer to my K value and my magnitude of my cell will go down. It's the opposite with electrolytic cells. These cells are thermodynamically unfavored. K is less than 1. So when Q is less than 1, that's going to mean the potential of the cell is going to go down. It's going to be less than what you think. And the magnitude, here you see absolute values, because these are going to be negative numbers. So essentially it's going to be closer to 0 instead of negative 1.5. It's going to be negative 4. But if you make your reaction quotient greater than 1, that would make the cell potential go up in magnitude. Right, let's look at an example. Here we've got a galvanic cell where my anode is zinc, copper is my cathode, and I have these two things each in these respective solutions. So look at your equations. You got to know your equations. This is what the oxidization. This is my reduction. The copper one is my reduction. That's going to give me this expression, net ionic equation. And remember that when I write my reaction quotient, solids don't go into the equilibrium expression. So now I'm increasing the presence of a reactant, this copper sulfate, right? This is non-standard condition. It's 2 and it should be 1. Therefore, my Q is going to be less than 1, all right? remember, for thermodynamically favored reactions, K is greater than 1. That means this is going to make my cell potential be greater than my standard conditions. All right? Now, think about it like, if you think about it, another way to think about it, if these are the actual reaction potentials, it's cathode minus anode. So these two things add up to 1.0. That means my cell would be greater than 1.0. Now, let's look at an electrolytic cell. Let's say I've got it in molten salt, all right? What's going to be reduced? My sodium is going to be reduced into salt metal, solid sodium, and my chlorine is going to be oxidized into chlorine gas, my chlorine ions. Here's my net ionic equation, all right? And now, here's my reaction quotient. These are going to go up. Now, this is going to make my Q once again less than 1, but in this case, my K is less than 1 as well. Therefore, this is going to decrease the magnitude of my cell, because this means I'm closer to equilibrium, and my cell potential will be less than standard conditions. So here is the solving for it, all right? And let's say this, so this is my value, negative 1.35 volts, and my actual cell value in magnitude would be less, so it'd be 1.2 volts. All right, thank you, and these are my sources for images and the like. Have a good day. Bye.